All right, and our last talk of the day in the container room is Jason. Jason comes from Datadog. He's a technical evangelist, and in his free time, he's a travel hacker. Jason, let's go.
Thanks. Quick question before we get started. How many people are using Kubernetes, just playing with it? All right, so you've all kind of played with this. How many of you are using it in production? OK, a fair number of people. Cool. So talking about Canary deploys, I mean, deployments, what could possibly go wrong, right? Like, yeah, a lot, everything. We've all experienced it. And so the issue when it comes to deployments, we've all seen the most interesting man in the world meme of when I do blank, I do it in production, right? Fill in the blank, YOLO ops. But the problem is when we deploy to production, we do that in production. Like, as much as we want to dry run things and test it, and we try to set up staging environments that exactly match production environments, like, at the end of the day, you still deploy to production, and there's no safety net for that. So that's why I suspect we're all here and interested in Canary deploys. So what are ways that we can actually deploy, start to get information without just having everything go to shit? So as mentioned, I'm Jason. I'm a technical evangelist at Datadog. I like to boil that down to saying that I do docs and talks. So I help write our technical documentation, which means reading through the code about what Datadog does, and then writing useful documentation, hopefully useful so that developers, engineers, anybody that wants to use the product can do so easily. And then I come to events and I talk. I'm also, as mentioned, a travel hacker. I'm currently a nomad. I live nowhere. I've been changing where I live, like cities around the world, every week. If you live in some place interesting that you love, come talk to me later, because I'm interested in exploring that. Aside from that, I love whiskey, and I'm still addicted to Pokemon Go. So if you see me wandering around like Pasadena later, I'm not lost. That said, if you have any questions after this talk, we'll have some Q&A. But if you think of something later, feel free to hit me up on Twitter. I'm getbisect. Email is jyee@datadoghq.com. A little bit about Datadog. Datadog's a SaaS-based monitoring, logging, tracing platform. We essentially try to make it easier for you to gather all the information about your system and have a central place where your developers, the rest of your teams, can all get together and understand what's going on in your systems. Give you an idea of the scale of what we handle, we do trillions of points of data every day. Just in the start of this talk till now, we've probably handled several 100 million data points. We are hiring. So that said, if you're looking for interesting new opportunities around large-scale systems, helping other people monitor their systems, we're hiring all over the board. And one caveat. So we're not really running Kubernetes in production yet. We're moving stuff that direction. So just like many of you, trying things out. So how did we used to do deployments? Or how do most of us do deployments? Is I think, how many people are doing BlueGreen deployments for stuff? Yeah? Wait, that's not very many hands. How many of you are just, what else are you guys using? What are you doing, aside from Canary deploys? Canary deploys, are people, everybody else using that? OK, also very few hands. Are people just not deploying? I mean, that is the safest way, right? The most reliable system is just never deploy again. Sorry? Yeah. Right, yeah. When things go down, you just deploy after that, and that's when you roll out the new code. So BlueGreen deploys, for those who aren't familiar, I think most of you probably are. Sometimes they're called red, black. It doesn't really matter the colors. The notion is essentially you've got a load balancer that sits out front, and you just flip a switch from version 1 to version 2 or whatever. Sometimes this could be in DNS. If you're thinking of code, people do this. This is the whole basis of Capistrano, right? Where you have one folder and you just symlink to that, and then when you have another folder of new code, you just symlink to that and make the switch. And the nice thing about BlueGreen deploys and why most of us are using that is that you get these really almost zero downtime deploys, right? You're changing a DNS entry. You're pointing a load balancer somewhere else. That doesn't take much time, and instantly you're flipping all of your traffic to that. And the other reason that we use that is for easy rollbacks, right? If I'm pointing everything to one location and then I switch it and, oh my God, that was horrible, things blew up, I can just hopefully switch that back. And we do this because outages cost money. We want zero downtime. So there's all these statistics about how much money outages cost us. 2013, Amazon.com goes down for about 40 minutes. People say that they lost about $5 million. A month later, Google.com goes down for 5 minutes, and they lose about $500,000. As mentioned, I'm a travel hacker, so I love the airline industry and the news around that. Do people remember the BA outage from last year? So BA had an outage on a Friday. It lasted the entire weekend, 800 flights canceled. They lost a ton of money from that. But one thing that I always like to remind people of when you're having outages is we often think of the time that it takes and the money that we're losing in sales, but there are other ramifications, right? How many people work in highly regulated industries, banking, things like that? Yeah, there are laws that go beyond just that. So travel industry, one of the fun things is if you operate in the EU, you are forced to pay back your customers for things like outages. So BA estimated that they had to pay out 61 million euros to their customers for this outage. On top of that, they're a public company, so their stock dropped 5%, which roughly equals about 67 trillion euros. But what does this mean to you? Well, your last outage, according to the Aberdeen Research Group, your last outage probably cost you about $100,000 per hour. That's their average across most businesses. But one of the other interesting things is, we talk about deployments and we talk about outages, but those don't protect us. Like, as good as our deploys are, they don't protect us against the bad code that our developers wrote that we're pushing out. Slowness costs us money. So if we think about just the applications, Walmart.com has correlated that 100 milliseconds of latency in their application equals about 1% of revenue. Mozilla, they shaved 2.2 seconds off of their website, and that equates to about 10 and a quarter downloads per year, million downloads per year. Your slowness. So interestingly enough, if you deploy code, if your developers write some code that's slow and you deploy it, 28% abandonment rate per second of extra slowness. And you compare that to an actual outage. Outages are actually much better. Outages, 9% of people will never come back. They'll permanently abandon your product for an outage. But if you make it slow, if you actually, as an ops person, did your job and deployed code and the code was bad and slow, that's much worse. So when I talk about BlueGreen Deploys, like undo, right? That was the whole point of this, was BlueGreen Deploys was you were flipping switches, you could easily roll back. But how many of you, like using BlueGreen deployments or something similar like that, had the easy rollback? Like, easy rollbacks are in quotes. I mean, occasionally you do, but rollbacks aren't nearly as easy as we would like them to be, or as they seem. So that brings us to Canary deployments. So for those who are in here who aren't familiar with Canary deployments, the notion is simply this. If I am going to do something ridiculously stupid up here on stage, would I rather have a room like this filled with people, or would I rather just have like one person, like just me and Josh here hanging out? So Canary deployments, really simple. You have a load balancer out front. You start diverting part of your traffic to another version. And if that works out OK, then you direct a little bit more traffic to that new version. And eventually, you get to cut over completely. So you're dipping your toe in the water, doing things slowly. And the advantages of this are that you have a small scope, right? And that means you have limited ramifications. So if things go horribly wrong, great. Only a few or a subset of your customers have experienced that. There's easier rollbacks. So because you're supporting two versions of the application at once, you don't have the problems of, oh my God, we updated the database and now it's incompatible with the last version of the code, so we can't roll back. It's load tolerant. So one of the nice things about Canary deploys is if you deploy new code and that code happens to use more resources, well, great, you've only done it for a small subset. You can monitor that and it gives you time to scale up your infrastructure to match if it is acceptable for it to use more resources. And the last reason that Canary deploys are really interesting is that you can do concurrency. So you can try out a bunch of new features and deploy them to different Canary groups and try to speed things up that way. That said, concurrency is often not recommended because running multiple experiments simultaneously can lead to some problems. So what does all of this have to do with Kubernetes, you're wondering? Well, Kubernetes is a container orchestrator, right? Wrong. Actually, Lucy, who was up here for the last talk, asked what Kubernetes was, and that was the answer, container orchestrator. But that's wrong. It's actually a service orchestrator, right? Because if I were to imagine I built a car out of Legos and gave it to a kid and asked him what this is, he'd be like, that's a toy car, or that's a car. He wouldn't say, this is Legos. Similarly with Kubernetes, yes, it uses containers, but the base unit, the thing that it actually does, is services. By the way, I have stickers for Squirtlenetties if you feel like stickers afterward. I did say I was addicted to Pokemon Go. So the interesting thing, right, is if we built our system out of microservices and we have this network of all these different services, well, doing Canary deploys or BlueGreen with that, like this just doesn't make sense, right? You don't want to maintain an entire network of microservices as a secondary and have some load balancer out front redirecting traffic. So that's where Kubernetes comes in, right? Because Kubernetes, as a service orchestrator, allows you to, it handles all of that. It handles all of the networking communications between those services and what goes to what. And so if you needed to change out, or if you want to change out a service, Kubernetes makes that really easy. So then why service meshes, right? Istio is a service mesh. So what do service meshes like Istio provide us, or why do we want them on Kubernetes? And the first is they make service discovery easier. They also handle all the routing and load balancing. So you can start setting up routing and load balancing on your services individually. They handle timeouts and retries, right? So we can set arbitrary timeouts per service and how many times we actually want to retry. And they can handle policy enforcement. So your developers don't have to worry about how they're communicating to other services. For example, they might be just calling, using curl or some sort of HTTP API that may not be encrypted. The nice thing about service meshes is they can intercept that and put it over a TLS connection. And all four of these things are really nice because it abstracts away the network from the application. Your application shouldn't have to care about how they communicate to other services. They should just make those calls and be able to get that. So these are four of the big things that service meshes get us. And the fifth is that you get monitoring and tracing, right? If all network is now going through your mesh, well, your network can now see what services are calling other services. How long is that taking? So you can get a lot of interesting metrics from that. So how does it all work? We started with Kubernetes. You've got all the network traffic going through it for your services. First step is you add the data plane. So with Istio, you sidecar Istio, which means that now it's going to proxy all of the network communications. So they all go through Istio. But that's actually a lie. It's not actually Istio, it's Envoy. So Envoy is what Istio uses. It packages up automatically for you. But what you actually are deploying as sidecars is Envoy. The nice thing about this, though, is it means that the whole Istio ecosystem is modular. So if there's another data plane that you would like to deploy, you can actually use that. After you have that data plane, then you add a control plane. So this is essentially the guts of Istio. It's where all of the logic happens, all the configurations go through this. And similarly, if you don't like Istio, but you want some other service mesh like Containerd or Linkerd, you can implement those. So let's talk a little bit about Istio. What is Istio actually comprised of? The main part that I think most people are interested in for Istio is the mixer. The mixer is the core, and it handles three main things. And the first is precondition checking. Precondition checking essentially being access control. So the second part is quota management. So quota management being rate limiting. So again, when we talked before about things like being able to circuit break or being able to do retries, things like that. So for example, with the quota management, you could say that a service, particular service, can only receive 5,000 requests per second. And the final is telemetry reporting. So again, adding in metrics, traces, logs, all of that data, because it can see what's going on over the network. So you have the mixer, which is the core of Istio, and then you have adapters. So adapters are how, if you want to integrate anything or you want to extend the capabilities of Istio, that's how you do it. So for the precondition checking, there are a bunch of things, but as mentioned, it's mostly access control. So right now in Istio, the four main ones that it's got is the denier adapter, which is essentially just the angry boss that says no to everything. You've got the list adapter, which allows you to do whitelists, blacklists. You have open policy agent, OPA, and role-based access control. So these are all of the precondition adapters that are currently in Istio. For quota management, there's only a couple. Memquota, which is the default, which essentially sets up all of your quota rules and tracks it in memory. The downside of that is if things go down, it's in memory, so that's gone. So Redis quota is also out there. It uses Redis as a backend for all of that. And then telemetry reporting. So there are a ton of adapters. Most of the adapters for Istio are around telemetry. So it started out with Prometheus and StatsD, but as we all know, there are a ton of monitoring companies out there. There are a ton of monitoring companies here in the sponsor hall and over in the DevOps Days sponsor hall. So a ton of stuff has gotten added recently. DogStatsD for Datadog, FluentD, Circonus, SolarWinds. There's just like a ton of different monitoring adapters. So whatever you're using, there's probably something there. All that said, go and check them out. They're all within the mixer/adapter folder on the Istio project. There's a bunch of stuff there. So now that we've covered Istio, what should be our container or Canary strategy, right? How should we think about doing Canary deploys? Well, random is probably the default. And that's the default in Istio. If you set up a service with multiple versions and you were to tell it what to just split between those, it would just do it randomly, essentially. But random's pretty decent if you're working in a service-based configuration, particularly if it's a non-customer facing service. So at Datadog, when we Canary deploy, we typically start out with 5 to 10% of traffic for any service will start being diverted to the Canary, and then we'll scale up from there. But Canary strategies, like random is bad when you're doing customer-facing canaries, right? Because random is uncontrolled. Real random is really hard. So you get weird samples that you actually can't control. So what you really want, particularly if you're doing Canary deploys for things that are customer-facing, is representative sets. And this requires knowing your user base. You have to understand your mix of users. So a few things to consider when you're considering your users is think about geography, right? For example, Grubhub does Canary deploys. They will Canary deploy to small cities like Detroit and then scale up to larger cities like New York before rolling things out globally. But keep in mind that different geographies have different cultures. You have to understand your users and how people in various locations use your application. Similarly, think of time, right? Different time zones. It's when you're doing Canary deploys, you have to keep in mind how long do you actually want to monitor this Canary. And if you do that, when are you deploying it, and is it actually a time that people are going to be using your application? And then finally, usage patterns, right? Similar to geography or times, understanding that if you Canary deploy and you're targeting a subset of users who all have a proclivity to use a certain feature of your application, how does that actually affect your stats or your monitoring about what's going on? And the other thing you have to consider is granularity, right? So you have to ensure that you have the right granularity. As mentioned, when we do services in the backend for Datadog, we start with 5 to 10%. And if you're doing essentially random canaries on a percentage, that's easy to scale up. But if you're starting to do representative sets, how do you scale up? How do you have a small size of users and then thinking of growing to a larger size? So again, thinking of like Grubhub when they deploy to Detroit first, small city, and then they can deploy to larger cities. So thinking about your users, how they actually use your application. And the final thing that I think a lot of people miss when they're doing Canary deploys is thinking about the resource mapping. So if you are trying to test a particular feature and you're rolling out a Canary to users that are heavy on that feature, how does that map to the resources behind it? What are the data stores that are running behind it? What are the applications that serve that? Are you going to start hammering those? So think about how the groups that you're presenting canaries to will actually use the application and what that means for the resources that are behind it. So then monitoring strategies, right? So thinking about now moving from what we're deploying to people to what we need to monitor. And the first thing with our monitoring strategies is tags. You absolutely have to be tagging everything. Right? When we think of a metric, we often think of it as a thing, a number, and a time. But if you're Canary deploying and you're mixing in this one experiment with the rest of your stuff, you absolutely have to have a tag to know that that's the Canary deployment. Other things that you have to do when you're monitoring, look at the extremes. So looking at your 90th percentile is common, I think, for a lot of people. But when you're thinking of canaries, you're deploying to a very small subset. So you have to look further at the extremes. So start looking at your 95th percentile, your 99th percentile. And then when you're monitoring, think about the outliers, right? The things that don't actually match. So compare your Canary deployment to prod. So I have to throw in more memes, but the outliers, right? The things that don't actually fit, they should be obvious that they're either not performing the way that they should be, they're in line with the rest of your services, or they're actually an outlier. The fourth thing to look at when you're monitoring your canaries is anomalies. So anomalies, I like to say, is it wasn't like this before. If you've got tools, particularly if you have a monitoring system that uses machine learning, this is a fantastic way or fantastic use for that. So taking a look and letting your systems analyze what were things like before, what should we expect, how is this behaving differently. And then when it actually comes to the things that you want to watch, I like the 4 golden signals. So the 4 golden signals is how Google does their monitoring or the things that they look at. It's part of the SRE book that they published. And the first is latency. So take a look at changes in latency. Are things taking longer, right? The next that they look at is errors. So not only the error rate, how many errors you're getting, but take a look when you Canary deploy at the types of errors. Have the types of errors actually changed? The third of the 4 golden signals is traffic. Has traffic changed? And this can be a big one, particularly if traffic goes down, right? If traffic goes down, you know people aren't doing the same things that they were. So take a look at your Canary, figure out where traffic ought to be, and judge against that. And then the final is saturation. So how are your resources doing? Is your resource usage the same as it was before? Is it the same as prod? Or is your Canary doing something different? And as said before, one of the nice things about canaries is that you can scale up. So if you take a look at it and you're like, yeah, we're using more resources, but that's expected, then great, start scaling up. So at this point, I was going to do a live demo and have you all pray to the demo gods, but the demo gods were very unhappy with me. But But it did bring to mind that 2 weeks ago, Kelsey Hightower gave this sage advice. Istio is an early project. Please don't run out of here and go deploy it in prod because you'll be on the news, and not in a good way. So Istio is a fantastic project. They're doing a lot of cool things with it. It's changing really, really rapidly. But that said, it's like not even alpha, really. So definitely encourage you to play with it. But don't put it in prod. You probably won't like that. If you are going to play with it, installing it is really easy. You go and download it, and then you unpack it, and then you add it to your path because you want Istio-ctl to autocomplete when you just type like IST and hit tab. And then you kubectl it. And that really is it. That's how you install it. It's pretty easy. So what happens when you kubectl apply on the Istio YAML? Well, it sets up a few services, and they're all namespaced within Istio. And the first is the Istio pilot. Istio pilot handles all of the Envoy API. So going back to that data plane, again, Envoy is what's actually sidecarring all of your pods. And so all your pods are talking through Envoy. Istio needs to understand Envoy. So the pilot handles the Envoy API, and that's how it can get the data. The pilot also is the platform interface. So I know we're talking about Kubernetes, but Istio actually has integrations now for Nomad, Eureka, Cloud Foundry, and Mesos. So Istio pilot is actually what would talk to each of those if you wanted to roll Istio out on, for example, Cloud Foundry. The next piece is the mixer, and that's what we talked about before. It handles the core logic bits. And then the final service that it'll implement is Istio Ingress, and this handles all the rules for inbound traffic. So what do you do next? So you install Istio. It's set up all these services. Well, then we have to let Istio actually do the sidecarring. So this is traditionally how you do it. You run Istio-ctl, kubeinject, and it will modify your YAML files, your manifests, and then you apply those in Kubernetes. So what does kubeinject actually do? Well, it does a bunch of stuff. It adds a bunch of stuff, but the main part is this, is that it adds an extra container. So again, it's setting up that Envoy proxy and getting that all running. It also adds a bunch of annotations, arguments that it needs in order to redirect all the traffic to that. Brand new, though, in Kubernetes 1.9, its beta, is the mutating webhook admission controllers, which has a really awesome name, I think, because it's super confusing. Anybody familiar with admission controllers? One person. So admission controllers really, in Kubernetes, they intercept requests. So when Kubernetes is going to make an object like a pod, it does some authorization, authentication, and then it has this period of time that it allows controllers or things to go and modify what's going to be done before it actually persists that. So the cool thing is that in Kubernetes 1.9, you have these mutating webhooks. And mutating webhook doesn't mean that the webhook mutates like itself. It means that the webhook mutates other things. So the nice thing about this is brand new to Istio as well, but it allows Istio to for you not to have to manually update your YAML file. It can simply have this webhook, and so whenever you go to deploy a pod or you make a deployment, after it gets authorized, but before it actually gets persisted, the webhook can go in there and be like, oh yeah, Istio should be on this. And so it can automatically modify that and add the sidecar. So this generally works based on labels. You'll label your default namespace with the Istio injection enabled, and then pretty much anything that gets deployed in that default namespace will get a sidecar. So Canary deploying with Istio, how would you do it? Well, you'd first set up a standard service. Istio doesn't actually touch any of your services. So you would have your basic service as a manifest. Pretty straightforward Kubernetes. And then you would make your deployments. And so when it comes to Canary deploys, with that one service, you would have 2 deployments if you're moving just from one version to another. And the main important parts here are that you want to label that with the version. So here, version 1 to version 2, and then obviously that has a different container as well. So we've got version 1 and version 2 tags on those. And then for Istio, you set up a route rule. So the route rule, again, is just going to tell us where we want to direct traffic. So the main part here that we're looking at is the route, and we're specifying that the labels of where we want to send traffic for V1 and how much weight. So the weight here being 100%. We want to send all of our traffic. And then in order to Canary deploy, if we're doing random, we would just add another label and say that now we want to send things also to V2, and we just change those weights. So in this case, we're sending now 20% of our traffic to the second version of our application. Now, I did mention like this is all random, so it's just going to bounce between those. At random, you can't control what users, but thankfully there are a ton of route rules out there. So you can also do things based on request headers. So for example, you can set a cookie, use some IP lookup service to determine where that user is, set a cookie, and then route based on that. So what else can it do? Well, it can do a ton of stuff. So that's the link to the Istio documentation. Circuit breakers are also part of routing, destination policy, load balancing, all of that is in there. That is a really, really long page of configuration things that you can do with routing. So just as a quick recap, when you're considering this, what do service meshes get us? Well, they get us more control. And I think that's why they're super popular. That's why I think most of you are here is trying to figure out how you can get more control over what's going on in Kubernetes. When we think about Canary deployments, recap is try not to do random, particularly if it's customer facing. Try to think about your users, because at the end of the day, that's your high-level work metric that you should be driving on. So think about how you can get representative sets based on your particular users and how they do things. And think of them in granular ways. How can you scale up? Because Canary deploying works best when you have multiple levels of deploys, when you can constantly ramp up more. And then when it comes to monitoring, ensure that you've got tags. Take a look at outliers and anomalies. And finally, have to be watching the golden signals. So look at the latency on your canaries, the errors, not only the rates, but the type of errors that you're getting, traffic, and saturation. And that's about it. Any questions? No questions?